I am discussing about an insight into solar photovoltaic models. Main components: photovoltaic models, inverters, module mounting structures. Photovoltaic models: crystalline, mono and poly, thin film, CPV, BIPV and DSSC. Solar cell. History: a solar cell is any device that directly converts the energy in the light into electrical energy through the process of photovoltaics. The development of solar cell technology begins with the 1839 research of French physicist Antoine Cesar Bequet. Bequet observed the photovoltaic effects while experimenting with a solid electrode in a electrolytic solution when he saw a voltage developed when light fell upon the electrodes. Solar cell actually work on the theory of a p-n junction. A p-n junction is boundary or interface between two types of the semiconductor materials, p-type and n-type, inside a single crystal of semiconductor. It is created by the doping. p-n junction is the elementary building block of solar cells. If the solar cell is put in the sun, photons will stick the surface of the silicon and pass their energy on the electrons. A typical proton can eject one electron from its nucleus, creating a free electrons and vacancies. These free electrons will feel the effect of the electrical field. They are pushed towards the junction on the n side and away from the junction on the p side. Likewise, the vacancies, which has a net positive charge, will be pulled towards the junction on p side and pushed away from it on the n side. This upsets the balance of electric charges. If an external current path connects the two sides of the cell, the electrons can be shipped back to the p side to reunite with their vacancies. As soon continue to heat the silicon cell, a steady flow of electrons or current is created. The power generated by the cell is the product of this current and the voltage created by the cell's electric field. Now, photovoltaic effects. Definition: the generation of the voltage across the p-n junction in a semiconductor due to the absorption of light radiation is called photovoltaic effects. The device based on this effect is called photovoltaic device. Some pictures of monocrystalline cell from Weber. Polycrystalline silicon cell, monocrystalline silicon models. Most efficient commercially available model 11% to 18%. Most expensive to produce circular cell created wasted space on the model. Polycrystalline silicon models. Less expensive to make the monocrystalline models. Cell stellite less efficient than a monocrystalline 10% to 16%. Square shaped cells fit into model efficiently use the entire space. Amorphous thin film. Most inexpensive technology to produce metal grid replaced with transparent oxide. Efficiency 6 to 8%. Can be deposited on flexible substrates. Better performance in low light condition that which crystalline models. Now, manufacturing process of amorphous silicon. Advantage: Batch process or provides for very high materials utilization as much as 3 times many. Comparating system and very high yield as much as 95% or more. Capital cost are low and system is stable from 6 cmW to 36 cmW or more. Production costs are low as compared to any other currently available technology. Production costs are low as compared to any other currently available technology per watt in low wage environment and lower with automated high throughput system. Amorphous silicon yield 10% to 30% more electricity generation per peak watt than crystalline system. Long track record of production reduce risk associated with many competing systems. CIGS thin film model. In recent year, CIGS thin film solar modeler has become industrially established as an alternative to silicon based solar models. The CIGS technology is mature and the worldwide production is now in the gigawatts year range. CIGS solar cell with a current record conversion efficiency of 20.8% for small area cell have the highest demonstrated efficiency of all thin film technique. Now selection criteria: price, space availability, efficiency, weather parameter, provenance of technology, specificational excellence, guarantee and warranty. Compare of mono-Si panel, poly-Si panel, thin film panel. Most efficient with max efficiency of 21%, less efficient with efficiency of 16%, least efficient with max efficiency of 12%. Manufactured from single Si cyclostyle, manufactured by fusing different cyclostyle of Si, manufactured by the depositing one or more layers of the PV material of substrate. Requires least area of a given power, requires less area of a given power, requires large area of a given power. Manufacturing process of SPV models. Processes during manufacturing of SPV models, part 1 and part 2. First one, doubling of cells, row making, stringing, lay up. Second one, part 2, lamination, curing, framing, testing, terminal box fitting and soldering. Now first, tabbing of cells. Process of making terminals of a wear cell by soldering copper strips to the bus bar. Second, raw making. A raw of the cell is made by the connecting positive surface of one cell to the negative surface of another cell. Third, stringing. The row of the SPV cell are connected in series to get desired power rating. Fourth, lay up. In this process, solar cells are put in between various layers for lamination and curing process. PV model electrical connection, single line diagram given below. Blocking diodes. When the sun shines, as long as the voltage produced by the panels is generated, then that of the battery charging will take place. However, in the dark, when no voltage is being produced by the panels, the voltage of the battery would cause a current to flow in the opposite direction. Thus, the panel which can lead to the discharge of the battery. Hence, a blocking diode is used in the series with the panels. Normal p-n junction diodes can be used blocking diodes. To select a blocking diode, following parts should be kept in mind: the maximum current provided by the panels, the voltage rating of the diode, the reverse breakdown voltage of the diode. Solar panel specification, electrical specifications, model efficiency. Define the conversion efficiency given by a given model, which is generally lesser than the single solar cell used in the models. Example 15.3%. Second, operating temperature defines the range of the temperature for which the model can function. Example 14 degrees Celsius to 85 degrees Celsius. Third, power tolerance defines the range of the power division from its started power ratings due to the change in its operating condition. It is defined in percentage. Example 0 plus 5%. Fourth one, parameter defines under NOCT. These parameters are same as defined under STC conditions with different values. Difference between STC and NOCT. STC standard test conditions: irradiance 1000 watts per meter square, model's temperature 25 degrees Celsius, air mass is equal to 1.5. NOCT normal operating cell temperature, irradiance 800 watt per meter square, ambient temperature 20 degrees Celsius, wind speed 1 meter per second. Fifth, temperature coefficients. These coefficients are defined to show the possible rate of the change of the value under varying model temperature and irradiations, and irradiance design implication. These parameters can be used to calculate the power, current and voltage of the models. Temperature coefficient of VOC can also be used to determine the maximum panel voltage at the lowest expected temperature. Packing configuration: piece per pallet, pallet per container, pieces per container. Now, effects of temperature. As the PV cell temperature increases about 25 degrees Celsius, the model V decreases by approximately 0.5 per degree Celsius. Effects of low isolation. In isolation decreases, ampere decreases while voltage remains roughly constant. Effects of the shading on PV models depends on orientation of the internal model circuitry relative to the orientation of the shading. Shading can half or even completely eliminate the output of the solar array at this moment of the time. The shade portion acts as a load and that creates hot spots. The bypass diode plays as important role in this situation, it by headed stringing. Thank you.